Hi all, welcome to Data Adoc YouTube channel and today's stream number 63. For today's there is an interesting topic about like visualization, data visualization. So recently there is was visualization or map presented by for from a science organization for toxic metals abundance in soil worldwide, new global map revealed. So here we can see all the details they have provided. In short, it reveals transcontinental corridor of metals laced soil that stretches from southern Europe to China, as well as hotspots across Africa and the Americas. The study estimates that everywhere from 900 million to 1.54 billion people worldwide could be exposed to elevated levels at least one toxic metals, with 14% to 17% of global farmland potentially affected. So we can see that severity here. I have Let's go to article. I am not going to get into exact details about what are these things, but I will move to directly map and try to understand. But to get abstract, they analyzed global database of soil pollution by arsenic, cadmium, cobalt, chromium, copper, nickel, and lead. So these are toxic metals, and they have collected 7,96,084 sampling points from 1493 regional studies and used machine learning techniques to map areas with exceeding of agriculture and human health thresholds. So they have proper database with them. So this data with sampling points across the globe, uh, we can see that this study is very pretty much accurate. They reveal previously unrecognized high risk metal enriched zone in low latitude Eurasia, which is attributed to influential climatic, topographical, and anthropic condition. So previously, because of this high sampling points, previously unknown, unrecognized high risk metal enriched zone from Eurasia, so that those region now get highlighted in this map. And uh, like outcome of this, as 14 to 17% of cropland is affected by toxic metal globally, and estimates that be between zero point 0.9 million, zero point 0.9 to 1.5 billion people. So it's directly affecting our food chain, and it's getting mixed in food chain, and ultimately it's going to harm our ecosystem with food, with nature in overall. So let's go to uh, map. So we can see that this corridor they mentioned previously, and we can see that probability 1 to 0, when we see this dark brown color where this particular area is affected, and wherever we can see this white, I think those parts from those region sampling were not done, and we can and I think it's not required because this less humanized area, there are less population from those area, Africa, then this is ice belts, and this is Australia region where population is very low. So I think those area will be won't be affected for this overall study. For this A, we can see that aggregate distribution of this toxic metal. And for B, we can see that for it's showing United States or North America region. In this region, it's get just zoomed up version of this area. And for this is India China area. And like we can see this color like uh, IN is E for India region, then TH is for Thailand. uh, so okay. CD exceedance rate. So with pH, they have mentioned that for this scatter plot, like PK is, I think, Pakistan. Okay, so for Pakistan, that pH is high. India is somewhere in middle, and for BR Brazil is this pH is less. So we can see the distribution of those CD exceedance rates, average soil pH for different countries, and we can see that for uh, different cities. So let's go for next chart. We can have like similar charts for again map of metal concentration accident. So these areas like for one like China part or North America or Europe region, where we can see the metal concentration exceeds population density areas with a greater than zero point 0.5 probability metal exceedance ecological human health threshold. So I'm not able to get exact details, but we can see this for like different like uh, for different metals, toxic metals, what is the population density area. So population affected by toxic metals exceedance people kilometer. So see population density area. Okay, so here we can see how much population affected by for different region. As expected, India, China are the worstly affected, but also we can see this Middle East region as well, which goes to Europe way. Europe, this area is affected. See, I think I misinterpreted that C is where combined soil pollution by toxic metal with line with Sankey diagram showing proportion of dual cumulative pollution. So sorry, I'm not sure about this exact density histogram showing the relative frequency of exceedance probability of various continents adjusted by areas of each continent. So exceedance probability, we can see that for Asia is high, and for Oceania it's low, but North America is also second and South America third. So as we can see here, uh, this particular density diagram, I think it just reflects a figure A part. For this we can see that this is for natural and anthropogenic drivers of soil metal existence. So uh, here we can see that SM is for subtropical monsoon and HB for hemiboreal climate zone. We can see, and this is for global. So we can see this red is monsoon, those like how this particular natural uh, driver for soil for metal existence, we can see. So for India China, it is for natural driver is monsoon, and hemiboreal is the driver for Europe and North USA, or between USA and Canada. MHL. For E, we can see that global distribution of hilly mountain areas. So, mountain area with greater than 2% of area slope between 0.005, 0.02 mean sea level. So, these areas are hilly region. So, sorry again, I'm not sure. I'm just trying to understand. So this charts I'm not able to understand. Let's check. I global ratio of irrigated and mineral rich region. Okay, so they are highlighted in red and with proportion of irrigation. So we can see for this region irrigation is greater than 90% and ores and metal imports greater than 5% of merchandise import MI. So for this area they have like irrigation is greater for like India, uh, then for China region also, south like uh, South Africa related region we can see here. So okay, then last part, in last part we can see the structural equation modeling of irrigation, mining and plant pumping effect, leaching, weathering on existence rate and hazard level. So these particular different charts you can see, you can share this article with uh, your analyst friend, or also who are more concerned about natures and how we can save nature from this man made activities. And because ultimately it all if you ignore, ultimately it's come on it will come to your plate only, because it's related to your related to only our human food chain. So that's it related for data ad hoc stream number 63. I tried to understand those this article, like how I can interpret it more, but I'm not able to done completely. And but I tried to understand from my side as much as I can. So thank you for watching, and let's meet next time with another interesting data topic. Till then, thank you.